Everyone, in this video we will see some example problems on series type ohm meter. Series type ohm meter is very important compared to shunt type ohm meter. As I said earlier, a series type ohm meter dial is different and the construction is different, and calculation is also somewhat difficult compared to shunt type ohm meter. So let us take two example problems and simplify in the calculation of R1 and R2, and as well as some additional problems are also there. Now, in the first problem, a 100 ohm basic meter movement is to be used as an ohm meter requiring full scale deflection of 1 milliampere. So, given IM is equal to 1 milliampere. Let us always, it is a good habit to note down what are the given values so that we can have a glance and how to solve the problem. Okay, so IM is given, that is 1 milliampere, and internal battery voltage V is equal to 3 volts. Internal battery voltage is given, a half scale deflection making of 1 kilo ohm. 1 kilo ohm half scale, half of the full scale deflection, that is resistance value RH is given. RH is equal to 1 kilo ohm is required. Calculate the values of R1 and R2. And another problem is maximum value of R2 to compensate for a 3% drop in the battery voltage. Battery voltage is 3 volts given. After days goes on, what happens? Some battery life will be reduced. That means the voltage across the battery may be reduced. Here he is saying that 3% voltage drop. So 3 minus 3% of 3 volts. That is the drop across the battery. If you substitute that value in the R2, what is the value of R2? Okay, now first we will calculate the values of R1 R2. We know the formula of R2 and R1. So what is the formula of R1? R1 is equal to RH minus IFSD RH RM by V. This is the formula. So if you substitute all these values, RH is 1 kilo ohm, so nothing but 1000 minus, what is IFSD? 1 milli into RH 1 kilo into RM. What is RM value? RM is also given. Internal resistance is given. See, internal resistance, the starting only it is given. That is 100 ohms. Internal resistance is 100 ohms. So RM is also given. RM is equal to 100 ohms. It is 100 divided by, what is the V? V in the first case it is 3 volts only. So that is equal to 1 kilo, 1 milli, both cancel. 100 by 3 is nothing but 33. So 33.33. 1000 minus 33.33, that is approximately 966.7 ohms. So this is the value of R1. Now R2 is equal to, what is the formula of R2? IFSD RMRH by V minus IFSD into RH. So let us substitute all this. 1 milli, 1 kilo into 100 divided by V is nothing but 3 minus IFSD is 1 milli into what is RH? RH is 1 kilo. Very simple. So this 1 milli, 1 kilo cancel. Again this 1 milli, 1 kilo means 1. So 100 by 3 minus 1, 2. That is equal to 50 ohms. Now, what is the second question? Maximum value of R2 to compensate for a 3% drop in the battery voltage. See here. Voltage is given as, V is given as 3 volts. Now 3% 3% drop in the voltage, battery voltage, 3% drop in battery voltage. 3% drop in battery voltage. How to calculate then? Then V new value is equal to V minus 3% of V. That is equal to 3 minus 3% of 3. 3% of 3 means 3 by 100 into 3. That is equal to 3 minus 0.09. 3 minus it is equal to 0.09. That is approximately equal to 2.91 volts. It is the new value of V. That means after reduction of 3% voltage drop. Now in this what he has asked to calculate the value of R2 only, not R1. Okay, now R2 is equal to, why he is asking R2? Because R2 is the resistor connected across the meter in series type ohmmeter. R2 is the potentiometer which is connected across the meter to adjust the 0 ohms. R2 is known as zero adjustable resistor. Remember, R2 is known as zero adjustable resistor because it is used to adjust its value to get zero deflection. Okay, so R2 is equal to, what is the formula? R2 IFSD RM RH by V minus IFSD into RH. So 1 milli 1 kilo into 100 divided by 2.91 minus 1 milli into RH is 1 kilo. So if you simplify this, you will get somewhat 52.36 ohms. Okay. Now let us go to the another type of problem. Design a series type of meter. It is also same. Now let us note down what are the given values. IM is equal to 1 milliampere is given. And internal resistance RM is equal to 100 ohms is given. And next, half of the full scale reflection RH is given. RH is equal to 2000 ohms, nothing but 2 kilo ohms. Calculate the values of R1 and R2. Same, using the formulas what we have seen in the previous case. R1, first case R1 is equal to, what is the formula of R1? RH minus IFSD RM RH divided by V. IFSD RM RH divided by V. So if you substitute all this, you will get R1 is equal to some 1933. See, RH is equal to 2 kilo ohms, 2000 minus, what is IFSD? 1 milli into, what is RM? 100 into 2 kilo by, what is V? V here also it is V equal to 3 volts. 3. So 2000 minus 200 by 3. So if you simplify this, you will get 1933.4 ohms. This is the value of R1. Now, how to calculate R2? R2 is equal to IFSD RM RH divided by V minus IFSD into RH. So if you substitute all the values in this, you will get 200 ohms. Okay, same method, just substituting the values, you will get 200 ohms. Now, what he is asking, the range of R2 if the battery voltage varies from 2.8 volts to 3.1 volts. Very simple. In the second case, he is asking a range. That means the voltage is given. V1 is given as 2.8 volts and V2 is given as 3.1 volt. Instead of taking a single value V, here he has given two values. Now what we will do? We have to calculate the R2 for V1 and we have to calculate R2 for V2. So R2 for V1, if you substitute R2 value, or if you calculate R2 value for V1, you will get 285, approximately 285 ohms. And similarly R2, by taking the V voltage as 3.1, you will get 182 volts, 182 ohms. Okay, that means for the voltage range of 2.8 volts to 3.1 volt, the R2 resistor range is 182 ohms to 285 ohms. This is the calculation. Okay, so in this way we can simplify, we can solve the problems. Most commonly you will get series type ohmmeter. In the examination point of view, series type ohmmeter is very important compared to shunt type. Okay, and generally here in the advantage of this EMI subject is the questions, you will get the problems directly. Okay, there is no indirect question. Okay, direct questions will be given. We only have to do taking the calculator and substituting the values, getting the values. One thing you need to by heart is formula. Okay, if you don't know the formula, it is very difficult to do the problem. Okay, thank you.